Okay, I think I'll go ahead and get started. So let me just go ahead and, like I usually do, open up in prayer, and then I'll make a few introductory comments and we'll get into it. So, dear Heavenly Father, it's a blessing to be working with everybody in this class. I'm praying that you would have the material that we cover be clear, that people will be able to assimilate the things and get some good chances to code and have some fun with what we're doing. Also, I also pray that you would continue to help each of the students here to help them in their spiritual formation, Lord, that they can learn more about Scripture as they're getting a chance to be learning that in various courses and the theological concepts in which we guide our lives by. And we just ask you in our midst. In Jesus' name we pray. Amen. Well, welcome to our room. I'll stand up for a little bit here. I'm going to be mostly kind of like you, doing some navigating, trying to share some information. But one of the things that this room reminds me of is like when I was in your situation, being an undergraduate, going to school, when I had to program it, I actually had to go to the data center to do that. And so this is kind of what it was like with a raised floor and stuff like that. And you can see a couple of generations of monitors here. They're in the middle of trying to do some upgrades to this, but hopefully they'll eventually get those replaced. That's a little bit of nostalgia and stuff like that. But it's going to be, we'll have plenty of room. So we even have some more space. So if anyone else wants to join us, we'll be able to accommodate that. So now you kind of have an idea last week of how we're going to be running the course. And so Tuesday will be more focused on lecture. And Thursday will be more focused on hands-on coding. And so that's one of the reasons why Thursday, having it being virtual, where you can be at a place where you feel more comfortable coding, is a good call. So we'll continue along that thread. So the things that we've covered so far is we've gone through bags now, and I wasn't able to do that last Tuesday, but last Thursday I was able to give you a little bit of an introduction to what they are. And so for the various types of data structures that we're going to discuss, we're going to have a scenario where we first introduce the idea of what it is. Then we'll start to talk about the implementation, and sometimes there'll be multiple chapters that will talk about that. I was having a little bit of discussion with Will before we started in thinking in terms of algorithms, and that's a whole nother thing that we're going to be talking about is like, well, what is the best algorithm for accomplishing something? So we'll be talking about some searching algorithms, some sorting algorithms, and then we'll talk about mechanisms for having a way to compare them, which gets into the efficiency of algorithms. And so that'll be something that we're going to get into a little bit down the road. You'll see this chart a lot, and I'm trying to be a good teacher. I will do some repetition, but if I had to give this one chart, it would be the course trying to represent it in one chart. And every once in a while we do have a tour, and so this is the one thing that I would tend to show them. So in the future, when you guys are on interviews, one of the things that they'll likely ask you is, what do you know about data structures? Do you have any thoughts about that? And so as a result of this class, you're going to be prepared to have some ideas of like, well, I really like queues, or I could really see some interesting ways of using trees or decision trees. Along the line, when I was talking with Will about algorithms, there's something you're going to be exposed to, a binary search tree, where it could be something that's quite interesting and quite useful. And so we have these abstract data types that we're going to be putting into data structures and doing implementations of that in Java. And so we have these 7 different things that we're going to be focusing on, 5 of which that you will actually have an assignment that you'll be doing some programming, and 2 which will be extra credit, and I'd be more than happy to have you give it a shot. And that would be something that I would welcome you to be doing. Now, I did get a question or two about the project proposals, and probably one of the best ways to be doing that, if you're a little bit confused about that, is let's just have a little bit of a dialogue. Either send me an email or chat after class or before class. Typically be in here, say around noonish or so you can take advantage of that time if you would like. I always like to have people think like, well, what are you interested in? So either for your hobbies or your professional interests. And let's see if we could start to tie it into the stuff that we're doing here. You can think of this as like we're doing some data analytics. And so I'll use an example of something a couple classes ago, a person was really into the Tour de France. And so what are some of the characteristics of the Tour de France? You have individual riders, you have team riders. So you're part of a team when you're going in the Tour de France. You have daily winners and you have overall winners. And so every day they say who is a ranking winner. So it's basically who has the lowest time. They aggregate all the things that they've done, either sprints or endurance types of activities for the day. And so that gives you a nice rich data set that you can be thinking about. And so a bag, I'll just start with that, could be a collection of all the players for a team. Or it could be a collection of the top 10 finishers. And then that is your bag that you're then going to be thinking about. And you'll be doing some other things with different data structures to get some more insight about that. Who was the team that had the most representative in that top 10, that top 20, or what have you. So your general theme for that case might be the Tour de France. Other folks have done things like video games or a wedding planner. I mentioned that was one of the things that a person had done in the past. You name it, the sky is a limit, and it can be as closely related to things that you're doing now and planning to do in the future, or something that's more of a hobby or of interest. Another thing I'll just point out again is that when we do your coding, you need to have at least 3 .java files. One of them is going to be given to you, and that's the interface. The first one is bag interface.java. What that is saying is when you do the implementation of that abstract data type, and so the name of your implementation would be like array bag, implements bag interface is something that you're going to have as the first statement. What that is forcing you to do is you're going to have a certain set of methods. And so going back to the car example that I showed you, it'd be like saying that you need to have a steering wheel, you need to have a gas pedal, you need to have a gear shift, you need to have a brake. So these are the kind of things that have to be part of your implementation. That's kind of a generically, and I'll talk a little bit more specifics about what exactly needs to be in a bag. I've shared with you an example driver program for bags. And so what that does, it gives you the interface, it gives you the implementation of that interface, and then it gives a driver program. A driver program is a type of .java file that actually demonstrates that all of the methods work. An application is slightly different. This is where it gets thematically, you're talking about your area of interest. But a good place to start is just having a nice driver, if nothing else, if you want to be doing some of your testing on what you're going to be doing with your code. Let me see if there's any comments or questions about that. So what I'm doing is in the future, when you're working for somebody or have your own company, you're trying to bid on contracts, the first thing that you're going to have to do is write a proposal. So that's the reason why I'm calling this a proposal. So you could pretend like you're submitting a proposal to Google or the NSF or NASA, you name it. And basically they give you a certain set of criteria that you have to list in that proposal. And based on the merits of what they see in that proposal, that they're either funded or not funded. And so this is not going to be that formal, but at least gives you a perspective that that's the kind of things that we're talking about with that. So like I said, if you do have any questions about that, feel free to communicate with me and we'll go ahead and chat about that further. So last time we gave an overview of bags. And so what I'd like to cover today is get into the implementation. And we'll have a couple ways of looking at that implementation. The first one that we'll do is looking at things using arrays. And I think everybody is familiar with what an array is in programming. Pretty standard idea, conceptually easy to figure out. And so that's a good place to start. But one of the things that also that you have here, and it's a little bit hard because of the fonts kind of merge a little bit, but you can see that some of these chapters they're not bolded. Those are the ones that are Java. And so these are the Java interludes. When you're talking about an implementation, this is where you need to be thinking about the specifics of what language you're doing it. Our implementation is going to be in Java. And so there's some quirks, if you want to call it that way. There's capability, there's design choices that are made depending on what language that you're using. So I've seen versions of this where this material is taught in C++. You can also do it in Python, but we're doing it in Java. So therefore, this is where we want to be thinking about the characteristics of what is done there. And so let me just click over and I'll do a short video with the video notes that we have here and then come back to the lecture notes. But just I did check the volume and everything and it seemed to be working fine, but we'll just also double check it now. So as a group here. So hopefully the sound works. Give me a second. Let me see if I can try and. Sorry?
The intro looks like just videos. Not too much.
Is the internals just videos? I'm just trying to understand what your question is for the quizzes. Is that
So
what
we have different intro groups.
Every chapter has videos associated with it. So there's like a video, one video for the interludes is part of what's there. Go to my settings and see if I can boost this volume a little bit. Well, I may not be able to boost the sound any louder, so I apologize, but I'll just do the best I can. It won't be boomed to death, but it will.
Generics is when we use a placeholder instead of an actual class type when we're defining our classes. We say that the class is a class of generic data type.
So I mentioned this a little bit on Thursday, this angle brackets T, that's indicative of a generic type. And this is what we're getting a chance to get a little bit of insight into here.
The class type is then determined when the object is instantiated. We already had experience with this when we were working with the array list class. The array list class is a class of generic data type. The type of array list is not determined until our code.
So the way this is currently shown, we're saying it's of a type name. So we're saying that we don't have to be that specific.
In this example, we create an array list that will hold only name objects. Here, in this example, we create an array list that will hold graphic cards. The array list class itself is an example of a generic data type, and the type of entries an array list will hold is determined when we compile these statements. We can do that with any number of classes. Let's take this class, sum class. It has a specific type of data it works with. String. It has a private data field string. The constructor has a string parameter and initializes that data field with that parameter. It has an accessor method to return that data field and a mutator method that accepts a string value and sets the data.
So we're going to hear those terms off and on in the video notes, getters and setters. So mutators and stuff like that. So this is how you actually, you get something loaded in and write something out. Those are just some terms that you'll hear.
Data field to be that value. This is great if you only want to work with strings. But let's say that we have some very intricate logic here that we really like and want to use with any number of data types. We can make it a generic class. Well, let's say that we have some very intricate code in our class, some class, and we want to be able to use that with other types of data, not just strings. We could create a class with a generic data type. We would start out by using the class name and following it with an angle bracket T and closed angle bracket. Now, in our examples, we'll be using the capital letter T to represent the generic data type that we're gonna be working with. We'll create our data field and make it of type T. Our constructor would accept the parameter of type T. Our accessor method would return a value of type T. And our indicator method would accept the parameter of T. We wanted to create a class that's similar to the earlier one. We would place string inside angle brackets to be instantiated.
So what they're saying down here, this is the generics, and this is when we actually make an instance of that class. And this is where you can't use the generic here. This is where you have to specify. So here, some of you are going to be able to see it. It's kind of being blocked a little bit here, the string, and then below that would be point, would be you're doing an instant of whatever this class that you're developing.
For that class and pass a string as a parameter to the constructor. But now we could also create a class that will hold points as the data field. And have the constructor a new point. In this instance, the class, is able to work with points in the same way that
So we're making some reusable code and is a way. So this is a coding strategy that you may want to be thinking about, because this could be something you would want to apply in the future.
the strings in the earlier example. Now, a generic data type represents a class type, not a primitive type. If a client wants to use primitives in our generics, the client should use a wrapper class in the definition. For example, here, if we're going to have an array list of integers, we will need to instantiate an array list of the integer wrapper class. Similarly, if in our previous example, we wanted to have our sum class hold doubles, we would instantiate it with the wrapper class double. Some of the rules for classes that are generic type, we use the type parameter T. The only place we need to use the type parameter T in angle brackets is in the class's header. The T in angle brackets does not follow the name of the constructors or in any of the methods. We use T as a data type inside a class definition. And this T can be used as a data field data type, the type of method parameters, method return values, and local variables inside our method. The class name followed by the angle bracket T is the data type of the class name. We have a class name, not a subclass. The data type is subclass string in the first example and subclass point in our second example. Let's look at some sample generic class types. First, we have the class ordered pair. It'll be a generic type class that holds pairs of objects that can have their orders changed. When we define our class, it's not important to us what types of objects the client will want to store and change the order of. The client can decide that when we instantiate our class. We want to provide code that will allow them to set the two objects that are stored in our class, and then another method that will change the order of those two objects. We have two data fields of type T, first and second. We have a method set pair that has two parameters of type T. It sets our first data field to be the value of the first parameter, and it sets our second data field to be the value of the second parameter. Then our method change order changes the orders of two fields. We create a local variable temp that's of type T, that holds the value of our private data field first. Then we assign first to be the value of the data field second, and then second to be what's stored in temp. And we have a two-string method that will display the values that are stored in each of our data fields.
So when we get a chance to be thinking a little bit more about the interfaces, you're going to see a couple different ways of how this T will show up, sometimes in the angle brackets, sometimes not. And hopefully this explanation will help you sort of get a sense of that. But I think when we actually do some of the coding, it will also be clear when you see it that way.
Because every class is the same class object, they all have a two-string method. So whatever our data type T turns out to be, when the client instantiates our class, we should be able to display those data types. Let's look at some sample code that will test our thought. First, we create a new order object type string. We set the pair to be apples and oranges. We print them out in the current order. Apples should be first, followed by oranges.
So here we see the generic. Now we see that we're using strings. And so this is where we begin to see that now we're going away, we're applying this general code that could be used on multiple things, and we're applying it here in a specific scenario.
And we'll call our change order method, and we'll print them out in the new order. We should see oranges and apples. Next, we'll create two name objects, through the D and through the DOM. We'll create a new ordered pair, but this time we'll set the type.
So within the same class, we're using the same generic ordered pair. We're using it a couple different ways. For fruit, now we're doing it for another way here for here. So that's kind of cool. You can see how it can be used multiple ways.
We then set the pair of objects to be through the D and through the DOM. We'll print them out in the current order. We'll change the order and print them out again. When our code executes, we should see apples, oranges, followed by oranges, apples, then through the D, through the DOM, and then after change order, through the DOM, through the D. We can also have interfaces with generic class types. We will declare an interface with the generic class type similar to how we declare our classes. Then when we implemented the interface, we will implement it in a similar fashion to how we implement other interfaces.
So we're going to be having interfaces. The first one we're going to be talking about is bags. But here's a very simple interface just to try to talk about some characteristic that the items can be pairable. And we're not given a specific type, just that they can be pairable. So that just gives you an idea what we're talking about.
There are times when we may want to have the current class be the type that's implemented in the interface. For example, when we implement the comparable interface, we should implement the current class as the data type of the comparable interface. That could be a little complex though, when the class we're looking to implement the comparable interface is itself a generic type. If we wanted to have our class subclass, it's a generic type, to implement the comparable interface, we would need to put the entire class name and the generic type declaration inside the angle brackets for comparable. And this is how the statement is met.
Okay, that last part got a little bit complicated, but don't worry about that. You know, we're all trying to learn this. And so let's just kind of take it a little bit at a time here. And so I'll just go back to the lecture notes, and then I'll do just a couple video notes related to bags implementation. So we're covering this. And so it's basically, it's a placeholder for a generic data type. And so we can see how that would work. We saw this laid out in the code. And so if you want, you have these code stubs as a part of code that's available in Canvas in case you find that useful. So let's just now get into first of two implementations on bags. So now we know what a bag is, an abstract data type. It has certain kind of features. Just think of like a grocery bag, and you go into the store and you stick things in the bag. Very loose association. It's just the fact that they're collected. You can be thinking of it as a shopping cart. That's another way of considering what's there. And so we'll then get a chance to be thinking about, over two short video notes, what this array implementation of a bag would look like. So an array has a fixed size, and so there's pros and cons of that. And so we'll talk about the ability of having a resizing implementation. That means we're going to have some more helper methods that we're going to have to develop, but that'll be the second of two videos that we'll talk about. And so we'll get a chance to be setting this up, and then we'll start to be thinking about how we do the testing for that. And not most, but not all, for the beginning, for this first ADT, we'll see some implementations laid out. So let me just go click over to the first video. And like I said, the thing I like about the videos is they have some more interactive, dynamic ways of presenting the information rather than just having a PowerPoint chart, which may be a little bit harder to capture the concepts.
This lecture presents an implementation of the abstract data type bag using an array data field to store the items in the bag.
So what I showed last Thursday, and I'll show again this Thursday, here we see the interface here. You can see how those angle brackets are everywhere. And you see sometimes where there's a T. So this just gives you an idea of the syntax of how we handle with a generic type. So this means that you're passing something to or taking something from that method that's done. But overall, you can see that the top level, it has an angle brackets for how it's listed.
When you use an array to organize data, the implementation is said to be array-based. In future lectures, we'll present another approach to storing data in a collection. Earlier, we developed a Java interface for the ADT bag. The interface, bag interface. Each public method within the interface corresponds to an ADT bag operation. Our array-based implementation is called ArrayBag to indicate the type of storage used in the implementation. We'll use the same generic type T in the definition of ArrayBag that was used in our bag interface. The definition for the class ArrayBag could be fairly involved. The class certainly will have quite a few methods. For such classes, you should not define the entire class and then attempt to test it. We begin by defining the data fields. We already know that one is the array that stores the items in the bag. When working with a class, the constructors are implemented first so that the data fields can be.
So we're going to start to see this in the next couple of Thursdays when we talk about the Java implementation. Is that I always like to look at other people's code because you get a chance to see how they do their implementation. You can look and say, hey, I like how they did that. That's a good idea. That's a good strategy. And so some of these things, especially for like the first two implementation or two that we think about, may be making you scratch your head a little bit. But what you're going to see is they're going to have like multiple constructors. And there'll be a reason for doing that. They have a default size for the array, you know, when we're talking about array implementation. And then they have like, you can set that size to whatever value you would want. And so you're going to have constructors both in the implementation of that bag interface, as well as in your application or driver program. So just to give you a little heads up that you'll see that as we move forward.
Initialized before any methods are called. Next, we identify a group of core methods to both implement and test before continuing with the rest of the class definition.
One of the things I make a point to do is I would highly recommend you implement one method at a time. I've had some students, and gets into a strategy. Some of you guys are computer science, some of you guys are engineers, but it's still true in either ways, but in a slightly different domain. As gets into a strategy of how you build and test. And so I always like to use the idea of going from success to success. Have something that works, then add one thing to that, so then you know exactly where you need to be doing your troubleshooting. You want to get that first pass of your code working each step.
By leaving the definitions of the other methods for later, you can focus your attention and simplify your task. But what methods should be part of this group? In general, such methods should be central to the purpose of the class and allow reasonable testing. When dealing with a collection such as a bag, you cannot test most methods until you have created the collection. Thus, adding objects to the collection is a fundamental operation. If the method add does not work correctly, testing other methods, such as remove, would be pointless. Thus, the bag's add method is part of the group of core methods we implement first. To test whether add works correctly, we need a method that allows us to see the bag's contents. The method toArray serves this purpose, and so it is a core method also. Similarly, any methods that a core method might need to call are part of the core group as well. For example, since we cannot add an entry to a full bag, the method add will need to call is full. Once the core group has been implemented and tested, additional methods can be implemented and tested, either one at a time or in groups of related functionality.
Like I said, I'd recommend doing one at a time. And maybe you can think of what you would want to call a core function. They mentioned a few, but just try and do one at a time. And so one of the ways that I did that, and I'll show it on Thursday, is what I call code stubs. And what I did is an implementation is all it does is has a print statement. And so therefore you can get it to execute without errors. And then you do an implementation, a more complete implementation once you get that base set working.
To decide which data fields we need in our implementation, focus on the activities that the interface requires us to perform. We begin by using an ordinary Java array to represent the entries in the bag. With this implementation, your bag could become full, just as a grocery bag does. Another lecture presents an additional implementation that does not suffer from this problem, giving us a bag that is never full. Here we have our array.
So just as a little bit of heads up, we're doing an array implementation. We're going to talk about a linked implementation. There's also something called a vector implementation, which we're not going to talk about it in as much detail. That's more something that's in C++, but just keep that in mind.
5 names we want to store. When items are stored in our bag, we can place them in consecutive array elements. Storing the items in consecutive array elements helps with the bookkeeping necessary to manage our bag. Now suppose we want to remove Ted from the bag. That array element becomes vacant. If we still want bag entries to be consecutively numbered elements, however, one entry will need to move into array element 2. Since the bag entries are not in any particular order, if the entry in the last field element moves into the vacant element, no other elements need to move. We can continue to add new items in the.
So you can see by what they're saying, this kind of gives you an idea. You're mindful of what a bag does. There's no particular order. So you can just put something else. If you take something out, you just put something else in its place, and that's going to help you out. When we get into some of the more complicated data structures, the abstract data types, we'll see that we're going to have to be using more care to be filling that in and moving things out. But this just gives you a very simple strategy.
Remaining elements. But eventually the array will become full if no elements are removed. So let's define the data fields we need. Here's our array bag class in UML. The array bag that holds the group of objects is an array of the generic type T.
So just as a reminder, you see how the nomenclature here, we'll talk about this on Thursday. It's a convention that I have you guys think about using. You may want to qualify this a little bit. So with your application, you could call it an array bag, but maybe it's like, you know, top 10 array bag or something like that. If you're thinking like the Tour de France, whatever it is that you're doing, but this is the way it's just reminding you doing an array implementation. Say you want to try a linked implementation and you want to do a shoot off, which is actually performing better. We have this implements. This is something I've seen that I want to have you in your code, and then you implement the bag interface. When we get into the stack interface, the stack, then you want to have the stack interface and so forth. We talked a little bit about UML. So this is just taking all these methods that must be implemented. And so these are the things that we're going to make sure that we cover. We can have extra helper methods that you'll see how that starts to come together as well.
The length of the array defines the bag's capacity. We can let the client specify this capacity, and we can also provide a default capacity. In addition, we want to track the current number of entries in the bag, so we can define a data field specifically for that number of entries. At least one constructor should be implemented before any class methods are called. You may leave that to be the default constructor inserted by Java, but in most of our data structures, we want to control the initialization of our data fields, so it's not common for us to use Java's default constructor, even when our class only has a default constructor. Our constructors must ensure all data fields have been properly initialized. In this case, it means initializing the number of entries in our newly created empty bag to 0. The constructor for this class must create the array bag. Notice that the declaration of the data field bag above does not actually create an array. Forgetting to create an array in a constructor is a common mistake. To create the array, the constructor must specify the array's length, which is the bag's capacity. The decision to use a generic type in the declaration of the array bag significantly impacts how we allocate this array within the constructor. The statement here is syntactically incorrect. You cannot use a generic type when allocating an array. Instead, we allocate an array of objects of type object. However, problems arise when we try to assign this array to the data field bag. This statement causes an incompatible type syntax error because you cannot assign an array of type object to an array of type T. That is, the types of two arrays are not compatible. A cast is necessary, but this creates its own problem. This statement produces the compiler warning. The compiler wants you to ensure that casting each of the entries in the array from type object to the generic type T is safe. Since the array has just been allocated, it contains null entries. So we know the cast is safe. And so we instruct the compiler to ignore the warning by running a special annotation, suppress warnings unchecked, before the offending statement.
Okay, so you have the sample code that I shared for a driver program for BAG. You also have all of the code that's shown in the textbook as another zip file that I've shared with you. So even if you didn't follow what they just said, you can just stipulate just to use that and say that this is a mechanism for using this kind of coding strategy that gives you this flexibility. You can have a default capacity, you can put it in a specific capacity, and some of the other things that we're trying to just set up there.
But this instruction to the compiler can only precede a method definition or a variable declaration. Since this assignment does not declare bag was already declared as a data field earlier, we make one more revision to our constructor, creating a local variable to temporarily reference the new array and then assign that array to our bag. The process we went through to develop the statements for creating the array may have been a little bit complicated, but now that you understand why each statement is necessary, creating arrays of a generic type will be easier in the future. To help simplify our code, we can have any other constructors we decide to implement called this constructor.
So this is a constructor, and here's another constructor. So here's what you're going to see in the code that we'll have for the sample things I'll be walking through. They typically have more than one constructor. I simplified it in I think the one that I shared with you. I think I just have, it has one constructor, but you'll see in this kind of construct as we move forward. And hopefully this explanation helps to shed some light on that.
Now that our data fields have been decided and initialized by our constructors, we can implement core methods. Let's see which methods we may need to determine characteristics of the collection after it's created. So
as again, this is from the interface. And so each of these methods has to be implemented. So for you, unfortunately, this is the first abstract data type that we're doing, and it actually has more methods than say we have for stack and queues. So I apologize for that, but once you get into the groove, I think you'll be following what we're doing.
We need to determine if the bag is full. This can be a simple test that compares the number of entries currently stored in the bag to the bag capacity, which we can get from the array length. Now, this was not part of the bag interface. It's a method we need because in our implementation, we decided to use an array. Therefore, this will be a private method. Newly created bags should be empty, so we can use the method.
Okay, so if we have like some private methods, this is part of the things that's not exposed to the user. Okay, so having a steering wheel, they don't need to know if there's power steering. You just need to have a steering wheel. That's like an example of an implementation. That's what we're getting in here is how this is if we're doing an array implementation, we need to have some way to track if it's full or not. That's something that the user doesn't need to know.
It is empty to validate that a freshly created bag has no items. The number of entries data field should be 0. We can now check to ensure our bag is empty before adding items, and we can also check to see if it's full, so we know when to stop adding. So it should be safe for us to implement the method to add items to the bag. When you add the first entry to an array, you typically place it in the array's first element. That is, the element whose index is 0. Doing so, however, is not a requirement, especially for arrays that implement collections. For example, some collection implementations we do can benefit by ignoring the array element whose index is 0 and using index of 1 as the first element in the array, so the item's position is the same as its array element. Sometimes you might want to use the elements at the end of the array before the ones at its beginning. For the bag, we have no reason to be atypical, and so the objects in our bag will begin at index 0 of the array. As we add each item to the bag, it's placed in the next array element, and we increment number of entries. For our method implementation, we need to return a Boolean that indicates whether or not we were successful in our add. In this example, we'll initialize it to be true and only change it if we fail. If the bag is full, we cannot add anything to it. In that case, the method add should return false. Otherwise, we simply add new entry immediately after the last entry in the array bag. If we were adding to an empty bag, the number of entries would be 0, and the assignment would be to bag element 0. If the bag contained 1 entry, an additional entry would be assigned to bag element 1, and so on. After each addition to the bag, we increase the counter number of entries. Finally, we return a result to indicate to our client whether or not the add was successful. Another technique we can use to create this method is to stub out the method first. We create a Boolean to return and then return it. That's all.
This is what I recommend in terms of get everything implemented very simply by having a code stub. Maybe you're going to put a print statement. It is kind of like that way you know that it actually got to that piece of code. Then one at a time, you can start to fill in the details. And I think you'll find that you'll, at least for me, I've had times when I just try and do it all, and then I can never figure out what is a mistake, or maybe I have 3 or 4 mistakes. It'd be nice if you know that you just had at most 1, you can fix that and then move on.
Since no item was added to the bag, the Boolean should be false to indicate nothing happened. Why do this? As you'll see shortly, when implementing an interface, all methods must be implemented before the class can compile. We don't always want to implement every method completely at first, and we shouldn't implement every method completely at first either. But to test the class, we have to have some form of minimal implementation. This is called a stub. Generally, a stub is just a return value that indicates failure of the function or has no meaning to the client. If the method is a void function, just braces are enough. Once other functions have been tested, we can complete the stub. In this case, if the bag is not full, we add an item and increment number of entries and set the result to be true to indicate success. Now that we're adding items, it would be helpful to have a better idea of the success or failure of our actions. We need a complete report on what is stored in the bag. The toArray method can provide us with that. Since we use an array to store our bag items, we could just return a reference to that array. It seems this method could be very simple. But even though this meets the explicit requirements of the ADT bag specification, it is a very poor programming practice. The array bag is declared private so that the data structure controls access to the array itself. The client should not be able to manipulate the data structure's data directly.
So how many people here are into cybersecurity, or that's something that you're thinking about? This is an example of one of the things that comes up in this course. They do talk about good coding practices. How do you protect your gold standard, your data set? You can get them a copy and they can manipulate it however it want. That's what you want. You don't want them to have access to things that they're not supposed to. You don't want them to override methods so they can actually make an implementation that's going beyond what you want. Those are all some things that we'll be touching base on. And so this is what they're trying to get at for this part of the implementation.
Giving the client direct access to the array bag permits the client to change and remove elements. If the client does this, internal bookkeeping variables such as number of entries will not accurately reflect the number of items in the bag. This leads to what's called an internal inconsistency in the data structure. It destroys the integrity of the bag and can result in many hard to trace errors. It's a better programming practice to return a copy of the array or any other data field in the class. As we said earlier, in implementing the constructors, since we need to create an array of generic type, we have to suppress compiler warnings, create an array of objects, and cast them to the generic type. We can then copy the entries from the array bag into this new array and return the array to the client. At this point, we have all our data fields, constructors, and core methods implemented. Before we
So I would argue that this means that you've done individual coding for each one of these. First, you have a code stub for everyone. And then you just gradually, you can pick one or what you think are the most important, or just go from one and work your way down the list. You could do it that way in a sense as well.
we can test our class, we have to stub the other methods in the interface. We can have get current size return -1. This would be a clear indication to the client that the method's not complete, since we'll never have a negative number of entries in our bag. The method remove can return null, which indicates the remove is not successful. And that's a fact because we actually haven't removed anything. Similarly, the method to remove a specific item should return false since the item will not be removed. The void method clear only needs braces. The method get frequency of can return -1 to indicate an incomplete method. And the method contains can return false because it's not implemented. It can never determine if the item is in the bag. It's not important that these functions are not correctly implemented at this point. We want to ensure we have a small amount of completely error-free code in each so that we can focus our debugging efforts on the methods that we did implement, the constructors and core methods. In an earlier lecture, we discussed
So what I tend to like to do is, just so I know that it actually went to that method, is put in a print statement. But this is definitely what it's talking about as a minimum kind of capability that you would want to make sure that you include.
items in the bag. It's not important that these functions are not correctly implemented at this point. We want to ensure we have a small amount of completely error-free code in each so that we can focus our debugging efforts on the methods that we did implement, the constructors and core methods. In an earlier lecture, we discussed developing a detailed test for an ADT implementation. So here, we just highlight the possible sequence of activities to test our implementation so far. To begin testing, we can create at least 2 new array bag data structures. One using the default constructor and one with a client-defined capacity. After creating the bags, we should validate that they are empty and not full. We then add items to each bag and use the toArray method to validate that the items we added actually appear in the bag. Finally, we can fill each bag to capacity and validate that it is full and not empty when the number of items added to the bag matches the capacity of the bag.
So this is when you, first of all, before you can do anything, you want to make sure that your constructor is working and you make the bag. And then here are what they're arguing are things that you would want to do, add and fill. So as you guys are writing your application program, building upon the driver set of code that I shared, these are the things that you could start with.
We should also try to continue adding items to a full bag to validate that those adds fail. It's as important to test for failures as for successful activities. After successfully testing and debugging our core methods, we're ready to continue and implement additional methods in the array bag. Next, we will implement methods to give us the status of the collection and of individual items in the collection. The get current size method is a simple implementation that returns the value of number of entries data field. The method get frequency of must iterate through the array bag and increments a counter each time an item equals the parameter that was set as a target. We start with the parameter and entry to be the target. and loop through each entry in the array, being sure not to go past the last entry in the array. We do not loop through the array elements that do not hold an item for the bag. We check to see if the current entry equals the parameter. If it does, we increment our counter, and then once the loop ends, we return the counter. The method contains has a different implementation since we're only concerned with whether or not an element is stored in the bag and not how many times it's stored. We initialize our boolean to return was found to false, since at this point in the method, we've not found the item.
Maybe just to make another point. So this is an example, you're getting a chance to see someone who's an expert in coding, give their strategy and how they're doing this. Some of this may make sense. Some of it you may be scratching your head a little bit. So you have the textbook. And so that's one way that you get a chance to have this information. You have these video notes with one of the authors who's walking you through it line by line. And so I think those are some things that you can get a chance to help you get up to speed. And then you're going to get a chance to practice by doing something on your own. A lot of this code you're going to have as it's written, anything that's in the textbook, that's going to be, you have that sample code as a reference. So just to give you an idea, you may be tracking this, it may take a little bit of time for you to be following it, but especially in the beginning, you'll get almost complete code. And then towards the end, they're not going to repeat what they've already covered, but talk about the things that are new for those more complicated data structures.
Here we have a compound Boolean test. We only search through the array until we find an item. And we've not reached the end of the bag of entries. The earlier get frequency of method always completes the loop number of entry times. This loop will terminate sooner if the item is found. If the current entry equals the target, we set was found to true since we found the target item, and so the bag contains that item. This causes the while loop to terminate also. If the item did not match, we increment the index and repeat the loop to check the next item. The final methods we need to implement are those that remove items from the bag. First, we implement removing an item, then all of the items. Last, we implement removing a specific item. The remove method must first declare an object of generic type T that we can use.
So we're going to find as we do like these add and remove kind of things, depending on what type of data structure that we're using. It can be easy or complicated. There's no numbering convention for a bag. So literally, if you're trying to find an item, you have to go one at a time till you find it. So you're going to see what conceptually can be simple to understand, but harder to do in implementation.
To store the entry that we're removing. We initialize the subject to null. Then if we're unable to remove an item, this value can be a signal to the client that no item is removed. If the bag is not empty, we then copy the last entry in the array into result and set the last entry to null. Setting the entry to null is a safety feature to clearly indicate that no item of value is stored in this array element. The order of these two statements is very important. If you set the array entry to null before saving the value in that array entry, you lose the data stored in that array element. After saving the item so we can return it and setting the array entry to null, we have officially removed the entry and can decrement number of entries to reflect this. The clear method is simple to implement if we use methods that we've already completed. We can loop, continuously removing items until the bag is empty. Because the method remove decrements number of entries for us, we don't need to worry about that here. Removing a specific item is the most complicated method we need to implement. Let's look at how it works. Here we have our array that stores the items in our bag. Our client asked us to remove a specific item from the bag. This is our target entry. This item is passed to us in the parameter and entry. We then compare that item to each item in the bag, starting with the first item. While comparing the target to each entry, we track the entry we're comparing using the variable index. When the target matches an entry, we remove it by copying the last entry in the bag into that slot.
Maybe I'll make a comment here since Will was talking about algorithms, and we're not going to get a chance to talk about that until later. But when we get like into, say, like stacks or lists or stuff like that, we can start to be applying, well, okay, how do we search for something? And so you can either have like a selection, sort, or search where you bin things. You say, is it in this half? It's in that half. And if it's not, then you can throw out that other half and you can search through that. You can start to have some quicker type of performance, but literally you're just going to have to go one at a time for this kind of thing that we're talking about here.
We then set the array element that used to hold the last entry to null and decrement the number of entries data field to reflect that an item was removed. Let's look at the code behind this. Because we need to search through the bag as we did in the method contains, we need a Boolean to indicate whether or not we found the item to remove and an index to track which item we're comparing to the target. Our while loop takes us through the array bag until either the target is found or we've reached the last entry in the bag.
So we're iterating through the whole array.
If the current bag entry matches the target, we set was found to true, copy the last entry into the position of the entry that matches the target, then set the last entry to null and decrement the number of entries to indicate that the item was successfully removed. So we have 4 specific actions we take when we do find an item that matches the target. If the current entry does not match the target, the index is incremented and we repeat the loop with the next entry in the bag. Finally, we return the Boolean was found to indicate to the client whether or not the target was found and successfully removed. The activities this method performs, searching the bag for a specific item and removing an entry, are shared by the contains method and the other remove method, respectively. A good optimization for this class would be to create 2 private methods that could be shared, one with contains and the other with the first remove method we covered.
So they kind of covered something very quickly at the very end when it says like a good implementation would be using some private methods, and then it gave a little bit of sense of that. So that is also a little bit of a reminder of some of the things that we're going to be seeing as we move forward. So the lecture note and the textbook has a slightly different way of giving a spin on how to develop it, thinking of a classroom analogy of how we can have an array. And so you can be reading through this in the textbook. And so this is all the sample code that we went through. So you can see that. So I'm not going to spend too much time going over that. Just kind of cycle through that. So like I said, I think that the video note has a better way of talking about it. It talks about the different type of constructors, the type of variables that are there. So you have all of that. Implementing the core methods, we had that, and then we had code stubs, so you could actually run it after you do those code methods, and it'll get it to work. You're not going to have all the functionality that you would want, but it's definitely going to do the thing that you would like to do. The thing that we haven't talked about yet, and this is what's going to be the final thing that I'll share. This will be the second video on the array implementation of bags, is how to do a resizable array. Anybody have an idea why you would want to resize an array? They actually mentioned it, but I just wanted to see if anybody caught that. What would you do if, go ahead. Exactly. So this is one of those things, it's in your private implementation. It's not one of the public methods that is shared with the user. Okay. But this is like a much better approach would be to do something. So you could just say, sorry, to the user, we're full. You got to take things out. And you could argue that there would be situations that might work. You go to the grocery store and you only can fit so many items in your bag. What do? Either get another bag, or I guess that's all you're going to take home, right? And you put everything back else on the shelf. And those are the possibilities. Either get another bag, make a bigger bag, And so those might be some strategies.
This section presents the idea of resizing arrays so that we can implement an ADT bag that is resizable. An array has a fixed size, which is chosen by either the programmer or the user before the array is created. A fixed size array is like a classroom. If the room contains 40 desks, but only 30 students, we waste 10 desks. If 40 students are taking the course, the room is full and cannot accommodate anyone else. Likewise, if we do not use all the locations in an array, we waste memory. If we need more, we're out of luck. Using a fixed size array to implement the ADT bag limits the size of the bag. When the array, and hence the bag, becomes full, the method isFull returns true, and any future calls to the method add return false. We cannot add any other items to our bag. Some applications can use a bag or collection that has a limited capacity. For other applications, however, we need the size of the collection to grow without bound. One strategy for accommodating additional students for when a classroom is full is to move to a larger room. We can do something similar when our array becomes
We had to do that. So you got personal experience with that.
full. We create a new array of twice the capacity of the old one. And then we copy the entries from our original full array to the new array. By copying the data from the original smaller array to the beginning of the new larger array, the result is like expanding the original array. The only glitch in this scheme is the name of the new array. You want it to be the same as the name of the old array. Let's look at how we can accomplish this. Here's our original array filled to capacity with 5 entries. First, we create an alias to this array. At this point, both old data and my data reference the same 5-element array. We do this so that we do not lose our reference to the original array in the next step. We can now create a new array that is double the size of the original, 2 times its length. We assign my data to reference this array. Notice that if we do not assign old data to reference the original array prior to the statement, we would lose our array since we would not have any variable referencing it. Next, we copy each of the elements from the original array to the new double size array. Last, we set old data to null. This removes any reference to the original array, and so it is marked for collection. An alternative method is to use the copyOf method in the Java class arrays to copy the entries in the original array to a new double size array and then assign that array to my data. Resizing an array is not as attractive as it might first seem. Each time you expand the size of an array, you must copy its contents. As the size of the array increases, each time you expand it, the number of copies required doubles.
So this is the first time we started to be having to think about how well this is functioning. We'll be talking about something called Big O notation, and some of you have already have encountered that. So how good is your algorithm performing? So there's going to be a liability for doubling the size of this array. If it's 1,000 or 1,000,000, that's going to take a while to do that. And so as a result, you get into this idea, you add one more item to your bag, and all of a sudden it takes 10 minutes for it to say, okay, I've added it. You're going to be scratching your head wondering what's going on.
So expanding a 100-element array to 200 elements requires 100 copies. If the new array needs to be expanded, the next expansion requires 200 copies. Also, once an array is doubled in size, we cannot reduce its size so the extra array elements may be wasted. Let's see how resizing arrays can help us create a bag that expands in size when needed. We're going to create a resizable bag class that doubles in capacity when the array bag becomes full. This can be accomplished with only a few small changes. Let's change the name of the class to resizable array bag so we can just.
So once again, this gives you an idea of the strategy for doing your code. You have an array bag. You don't lose that. You make another copy of it. Now you call it resizable array bag. So now you have all of these different classes that are available to you. Say if for whatever reason you decide you want to use one or the other.
Distinguish between our two implementations. We must also change the names of the constructors to match the new class name. We should change the name of the constant default capacity to default initial capacity. Although it is not absolutely necessary, this change clarifies the new purpose of the constant, since the bag's capacity will increase as needed.
So this is like another way of doing documentation, is how well are your variables and everything that you lay out. You want to make it as easy for you and some other people to follow this code. Guess what? Let's say, for example, you're working for Google, you're doing this, and 6 months from now, someone else has to pick it up and follow on what you're doing. You need to have this clearly laid out in a conventional sense so that they'll be able to follow on.
We have to make the same change in the default constructor, which uses this constant. Since we must be able to reassign the data field to a new array when it is resized, we have to remove the modifier final from the declaration of the array bag. Since we are resizing the bag each time the array is filled to capacity, the bag will never be full. So the method is full should always return false. In our implementation of the method add in array bag, most of our statements were used to ensure the bag was not full or had sufficient capacity before we performed the add. Only 2 lines of code were actually needed to add an entry to our bag. Since now the is full method always returns true, the other statements are unnecessary, so we can remove them. Instead, we can define a private method to make this check and resize the array bag if necessary. Let's name the method ensure capacity. Also, since the bag will always have enough capacity for an add, the method will never return false, so it will return true at the end. Our private helper method, ensure capacity, should check to see if the array is filled.
So this is an example of things that we're going to be starting to see, and with some of the sample code you're given. In general, the coding convention they have is the public methods are on top, the private methods are towards the bottom of the class, and so you'll get a chance to be figuring that out. Eclipse, it can help you kind of go from one to another. And if you haven't bumped into some of those features, we'll get a chance to start to think about that on Thursday.
And if so, double its capacity using one of the algorithms we discussed earlier. So with only a few minor changes, we have an ADT bag implementation that uses an array to store the items in the bag, but always has enough capacity for us to add additional items.
Okay, well, let's review what we captured today, and I want to make sure to see if there's any questions. But we've gone over bags. Last week we introduced that. This time we did an implementation. Now you actually have some real code that shows you how to do a bag. So as you're doing your first project, this should give you a leg up for how you're going to go about doing that. We talked about all of the different types of methods that need to be functional for this to do what we would like it to accomplish. We've also had a chance to set up to figure out how to do a resizable version of that. So it's basically you're mitigating one of the liabilities that this type of implementation has. So Thursday we'll get a chance to be looking at how an array bag works. This is what I gave the sample code. And so let me just double check. First of all, does everybody have Eclipse working on their computer? Okay. Did everybody get the sample code that I shared put into your Eclipse? Okay, good. So start to take a look at that. Maybe start to do a copy of some of that and see if we can start to move toward getting you doing an application related to your theme that you want to be doing on your project. And if you still don't have that figured out, let's continue to have that dialogue. And like I've said several times now, what is something that you're interested in? What's a data set that you might want to be thinking about? And let's start to see if we can make it real of the kind of things that you'll be doing in the future. So any other comments or questions that people have? Okay, I'll see you all on Thursday. Do you guys like this room? Is this working better? Okay, good. Right, take care now. God bless.